So 7.2, we're continuing working with our normal distributions, and this one is going to be very calculator heavy. The calculator will do the work for us. We just have to know what to type in, okay? And there's a couple things to keep in mind. Back in Chapter 3, when we first started working on z-scores, we mentioned that z-scores, we always round to 2 decimals. And then as we're working through some problems, sometimes they ask us for a z-score, and we'll know that we'll round that to 2 decimals. But sometimes they ask us for an area, and we're always going to round those to 4 decimals. That's important for us to keep in mind when we're looking for a z-score and when we're looking for an area, because that's going to tell us what to round to. But it also helps us figure out what we're finding. So as we look at these different problems, and you may notice, oh, they've given us a number with 4 decimals, that means the number they're giving you is an area. Whereas here, they're giving us a number with 2 decimals. That means the number they're giving us is a z-score. If they're giving us a z-score, then our answer we're looking for will be area, and we'll round to 4 decimals. If the number they give us is an area, because it has 4 decimals, then we know the answer we're looking for will be a z-score, and we'll round to 2 decimals. So really use that to your advantage, okay? It's a subtle hint, but it can help you know which one you've got and which one you're looking for. Right here is the keystroke that you're going to use in your calculator, okay? If you are using, we're going to go into the second distribution feature, which we had before on our calculator in Chapter 6. So second, and then this VARS button takes us into second distribution. We are going to be focusing on number 2 and number 3, normal CDF and inverse norm, okay? So we're going to always be picking option 2 and 3. I'll show you how to work that in just a minute, okay? Notice that if you pick normal CDF, it's going to expect you to give it 4 numbers. It's going to expect you to give a lower bound number, an upper bound number, a mean, and a standard deviation. Now, if you're using an 84, it will prompt you, what's your lower bound? And you'll type it in. What's your upper bound? And you'll type it in. What's your mean? What's your standard deviation? And you'll type those in. If you are using an 83, it will not prompt you for those 4 numbers, but you just know that those are the 4 numbers that you have to use. So we're going to write it on our paper, and if you're using an 83, then you'll just know you have to make your paper look like what we're writing down, or what you have to make your calculator look like what we're writing down, okay? All right. The other thing we have to talk about is infinities, okay? And I'll show you how to do that in just a second, but it is a reminder right here on your notes that if you want the symbol negative infinity, we don't have an infinity button on our calculator, so we'll type -1e99, which is the calculator's way of saying -1 times 10 to the 99. That's scientific notation. And if we want positive infinity, we will type 1e99, which is the calculator's way of saying 1 times 10 to the 99th, which would be like a ginormous number, a bajillion or whatever. With the -1 in front, it would be like negative bajillion or something. So that's just kind of some shorthand that we'll use in our calculator, okay? So there's your calculator keystrokes if you need them, okay? All right. Notice, oops, got my pages out of order there. 2, 3, 4. Here's page 4. Here's what we're looking for. Okay, so example here. Find the area under the standard normal curve that lies to the left of a particular z-score. Okay, now remember, when they say standard normal, they're telling us that the mean is 0 and the standard deviation is 1. So I'm going to recommend that we draw a picture. Okay, you don't have to draw a picture. It's not going to be part of your homework necessarily, but I recommend drawing a picture. I think it will help you. Okay, since they said standard normal, we know the mean is right here at 0, and we know that the standard deviation is 1, so we would count by ones. I really wish I hadn't drawn that line. If you haven't drawn the line, please don't. Go ahead and leave that off. So we're counting by ones to the right, and we're counting by ones to the left. Okay. Now remember, the mean is in the middle. The mean is 0 because we're using standard normal curve. 50% of the people are below, 50% of the people are above, okay? And they ask us for the probability that the z-score is less than 2.29. Okay, this is a z-score. Remember, these are z-scores on the bottom. So 2.29 is about right here. Here's 2, here's 3, 2.29 is a little above 2, it would be about right here. They want the probability that z is less than that number, less than 2.29. They are wanting to know what percent of the people are in this region of the curve. Notice that's going to be a very high percent. 50% of the people are below here. So if we're going way out to 2.29, that's a lot of the people. I bet this is 90-something%. There's not very much empty space to the right. Okay? All right. Do you remember how we did binomial PDF and binomial CDF? Well, binomial PDF was for exactly a number. So if they wanted exactly 2.29, we could pick normal PDF. We are never going to pick normal PDF because they are never going to ask us for the probability of an exact number. They're always going to ask for the probability of it over to the side of that number. So we are always, always, always going to choose normal CDF. Okay? So notice over here in our calculator keystrokes, okay, it always says normal CDF. We will not use normal PDF. Okay, so in our calculator, we're going to hit second vars. We are going to pick normal CDF. Now notice my calculator, if you're using an 84, will prompt you. What's the lower edge number? What is the upper number? What is your mean? What is your standard deviation? Okay. All right, our lowest number, how low did our shading go? It went down here to negative infinity. But we don't have a way of typing negative infinity in our calculator. So we're going to type negative 1 E99. Now that's already in my calculator, but let's say that wasn't there. I would hit negative 1, and then directly above the 7 button, there's a comma, and above that it says EE. That's the E that we're talking about, is that EE that's on the comma above the 7 key. So I'm going to hit the blue second button, and I'm going to hit the comma button, and it pasted that E. And then I'm going to hit my 99. That is the calculator's way of saying negative infinity, since we don't have an infinity button. Okay, the upper means how far to the right did our shading go. Our shading went from negative infinity up to 2.29. So my upper number is 2.29. My standard deviation is 0. I'm sorry, my mean is 0, and my standard deviation is 1. And I know that because I'm using a standard normal curve. In standard normal, the mean is always 0, and the standard deviation is always 1. And I'm going to choose paste. Now, if you are not using an 84, your calculator will not prompt you for those 4 numbers, but you will have to type them in anyway. So you pick normal CDF, and then you typed in negative 1 E99, comma, 2.29, comma, 0, comma, 1, close parentheses. So your paper still says this. You write this on your paper, and that's what you type in your calculator. Okay, now remember, the number that we gave it, the 2.29, was a z-score. That was our cutoff number. So what comes out of the calculator is the area. We just asked the calculator. We said, hey, calculator, please give me the area under the curve between negative infinity and 2.29 when my mean is 0 and my standard deviation is 1. And the calculator is saying, oh, okay, the area under the curve is going to be 0.9, let me write over here, 0.988989372, blah, blah, blah. That's the area under your curve. Okay, well, remember, we're finding area, and we said a while ago that we were always going to round area to 4 decimals. So my 4th decimal is this 9 right here. Because the number after it is 5 or higher, that 9 will go up. If you send 9 up, it becomes a 10, which means that 1 comes over here to the 8, and then I'll have a 0 right there. So my answer is 0.9890. What that means is, let's say it was height, okay, how tall people are, what percentage of the people are less than or below 2.29 standard deviations. 98% of the people, that's what this is saying. 98% of the people are below 2.29 standard deviations. That's almost everybody, isn't it? Okay, let's try another example. Find the area under the standard normal curve. As soon as we see that, we know the mean is 0 and the standard deviation is 1. That lies to the right of a z-score. And their example is probability that z, that's a z-score, is greater than negative 1.02. Okay, well, since we're doing standard normal, zero's in the middle, and we can count by ones for our standard deviation. Negative 1.02. Well, here's negative 1. I'm going a little bit past the negative 1 to negative 1.02. That is barely past the negative 1 on the left-hand side. They want the z-scores to be greater than that number. Where are numbers that are greater than negative 1.02? Oh, they're to the right. So we are looking for the area to the right of negative 1.02. Okay, we're looking for area. So we're going to go to normal CDF. It's going to want our lower bound. The lower bound is where did we start shading at? We started shading at negative 1.02. The upper bound, where did we stop shading? Oh, this shading went for forever. This shading went to infinity. We don't have an infinity button, so we're going to use 1E99. Now it's positive 1E99 because we're doing positive infinity. A while ago we did negative 1E99 to represent negative infinity. Okay. Our mean is 0. Our standard deviation is 1. In our calculator, we'll hit second bars. We're going to pick normal CDF. CDF is cumulative, meaning we can give it a whole region. Our lower number, negative 1.02. Our upper number is positive infinity. We don't have an infinity button, so we're going to hit 1. E, to get the E, you'll hit the second button, and then the comma, which is above the 7. 99. That's our upper number. Our mean is 0. Our standard deviation is 1. Remember, if you do not have an 84 to prompt you for those things, you just have to know that it's your lower number, comma, your upper number, comma, 0, comma, 1. And when you type that in, it tells you 0.8461357, blah, blah, blah. We are looking for an area. They gave us a z-score. They gave us the cutoff number. We're looking for the area. Area is 4 decimal places. So 0.8461. Okay, so stop at 1. The number after the 1 is not 5 or higher, so it stays at 1. This means that the area of this region is 0.8461. That means about 85% of the people in the population are above this z-score. The other 16% would be below. Okay. Finding an area under the standard normal curve that lies in between two z-scores. Okay, so notice they're asking for the z's in between negative 2.12 and positive 1.25. Zero's in the middle. Negative 2.12. Well, here's negative 2. Negative 2.12 is a little bit past it, a little bit below. 1.25. Here's 1. So it would be, about a quarter of the way. 1.25. Be about right there. We want to know the probability of someone being in between these two z-scores. What percentage of the people are in this region of the graph? Okay, we were given z-scores. That means we're looking for this area. Okay, so we're going to choose normal CDF. Normal CDF wants the low end. What's the lowest you want to go? Negative 2.12. To the highest. What's the highest we want to go? 1.25. Our mean is 0. Our standard deviation is 1. This is what you're going to type in the calculator. Normal CDF. My lower number is negative 2.12. Upper is 1.25. Mean 0. Standard deviation is 1. If you do not have an 84, if you're using an 83, it's not going to prompt you, but you still have to give those same numbers. 0.877347, blah, blah, blah. We are finding area. They gave us z-scores, so we're looking for area. Area is always rounded to 4 decimals. 3 is the 4th decimal. Since the number after it's not 5 or higher, 3 is going to stay where it is. 0.8773. This means the proportion of people who are between a z-score of negative 2.12 and 1.25 is 0.8773. That's about 88%. About 88% of the people would be in this region. Okay? And notice, this is a big part of the graph. So if the whole area is 1, we just took a big chunk of that graph. So the area of our region is very close to 1. It's 0.87. That's not 1, but it's close to it because this was almost the whole region on the graph. Okay, page 5 here. Same idea, some very minor changes. Okay, this time, instead of giving us z-scores and asking us the area, they're going to give us the area and we have to find the z-score. Okay? So let's look at example A here. Find the z-score so that the area under the standard normal curve to its left is 0.0262. Okay, so we're doing standard normal curve. So I know zero's in the middle, and I'm counting by ones. I'm not going to put the numbers 1, 2, 3 yet because I don't know exactly where this line's going to be, but I just know zero's in the middle. Okay? All right, now they want us to draw a line somewhere on that curve so that the area to the left is 0.0262. Now, 0.0262 is a very small area. Because remember, if I put it right here in the middle, the area to the left, if I put it here in the middle, the area to the left would be 0.5. So I only want the area to the left to be 0.02. That is very small. So I bet you that this line is way down here in the tail in order for the area on the left to be 0.0262. That's a teeny tiny area. I bet this region is way down here on the left. And we are looking for the z-score. So I'm going to put a z and a question mark because I don't know what that z-score is. That's what we're looking for. Okay? Now, remember, normal CDF, we give it the region, the lower bound and upper bound, and it gives us the area. This time, we don't know the area. I'm sorry, we don't know the z-scores. What we know is the area. So here's what we're going to do. We are going to pick inverse norm. That's option 3, INV norm. Now notice what happens. In math, that term inverse basically means opposite or reverse. Normally, we give the z-scores and it gives us the area. But now we're doing it backwards. We're doing it opposite. We're doing it in reverse. We're going to give the area. We've got the four-digit area. We want it to give us the z-score. So we are going to pick inverse norm. Here's your calculator keystrokes. We did second distribution, inverse norm, and now what it expects us to give is the area to the left. So what is the area to the left of what we just drew? It's 0.0262. Okay? And then it wants to know the mean and the standard deviation. Our mean is still 0. Our standard deviation is 1 because they told us it was standard normal. Okay? If you are using an 83, it does not prompt you for those things, but it still expects you to type it in that way. So you pick inverse norm. It expects you to give the area to the left, so 0.0262. Mean is 0, standard deviation is 1. Okay, and our calculator says negative 1.9398, blah, blah, blah. Okay? Remember, area is 4 digits, z-scores are 2. Since we are looking for a z-score, we're going to round this off to 2 digits. So our z-score is negative 1.94. That is the z-score cutoff. 0.0262 is the area to the left of negative 1.94 for a z-score. Now, a few of you may have a newer calculator that does that a little bit differently. When you hit second vars and you pick inverse norm and you tell it that your area is 0.0262, it asks you to say whether the area you're looking for is on the left edge, the right edge, or in the center. So in this case, I would hit left, okay? And I get the same answer, okay? What the brand new calculators do is let you pick where that region is, on the left, on the right, or in the middle. The older calculators, the regular 83s and 84s, always assume that the area you're looking for is on the left. So that's why it always assumes you've got the left. Okay? Let's try another one. Find the z-score. So the area under the standard normal curve, that means mean is 0, standard deviation is 1. The area to the left is 0.9931. Okay, I know 0's in the middle. I know that if I run an inverse norm from here, the area to the left would be 0.5. But they're telling me the area to the left is 0.9931. 0.9931 is a very high percent. That's like 99%. That's almost everybody. So I bet that my line is right here because now I've got 99% below. 99% is to the left. I do not know what that z-score is. That's what they're asking us to find. But I know the area. So if I know the area and I'm looking for a z-score, I'm going to choose inverse norm. So second vars, inverse norm. The area I have is 0.9931. Notice that's the area to the left. If you're using one of the newer calculators, make sure you tell it left. The mean was 0 and the standard deviation is 1. And we get 2.4624 blah, blah, blah. What should we round to? Well, they gave us an area. We're looking for the z-score. Z-scores are always rounded to 2 decimals, so 2.46. So that means if you go to a z-score of 2.46, 99% of the data is below it. Okay. All right, last example for this video. For the standard normal curve, find the z-score. That's the cutoff for P70. Okay, think back to chapter 3. P70, I'll keep writing the Z. P70, excuse me, means the 70th percentile. That means 70% are below that number. If your baby is in the 70th percentile for height, that means your baby is bigger than 70% of the other babies. 70% of the other babies are smaller than yours. Okay? All right, so P70 is right here in the middle, 0. That means 50% are below. But we want 70% below. So I bet our cutoff is going to be right over here for 70% of our people to be below it. Now, we don't know the z-score. That's what we're looking for. But I know this area. If 70% are below it, that means this area is 0.70. They gave us the area. So we're going to inverse norm it. The area to the left of our cutoff is 0.7. Our mean is 0 and our standard deviation is 1. .7 is my area, mean of 0, standard deviation of 1. If you are using an older 83, you're just going to have to type the 0.7, the 0, and the 1 yourself with commas in between. Our calculator gives us 0.5244, blah, blah, blah. That is a z-score. Remember, we knew the area. We were looking for the z-score. So the z-score is 0.52. Z-scores are always 2 decimals. That means if your z-score is 0.5, 70% will be below you. Okay? Hopefully that will help. We will keep working some more examples like this in a 7.2 part 2 video.